Hi Senior Stage, Gail again. These are the answers to exercise 2 star. In question 1, you have ax plus b is equal to c. You need to make x the subject. The first thing to do is to subtract b from both sides. On the left side, ax plus b minus b. You balance that on the right hand side by having c minus b. On the left side, b minus b gives you 0, and so you're left with ax, and on the right side you've got c minus b. Now you have to divide by the a in front of the x to get rid of it. So you divide by a, and on the right hand side you must remember to divide both terms. On the left, a divided by a is 1x, and on the right you have c over a minus b over a, and now x is the subject. In number 2, d is equal to x minus b over c. To get to x, which is at the top of the fraction, and the fraction line behaves like a bracket, you need to multiply both sides by c. On the left, you have d times c, and on the right, x minus b, I've put the brackets in this time, times c. On the left, you have dc, and on the right, c divided by c is 1, and so it will be equal to x minus b. I don't need the brackets anymore. Now I'm going to add b on both sides so that I can get x by itself. On the left, I'll have dc plus b, and on the right, I'll have x minus b plus b, which gives me 0. And so on the left, I have dc plus b is equal to x. And we know that we have to write x as the subject of the formula, so it's x is equal to dc plus b. Number 3, c is equal to bx over d. X must be the subject. It is over d, so we're going to multiply both sides of this equation by d. Multiply the left by d, and multiply the right by d. On the left, you have CD is equal to, on the right, d divided by d is 1, and so I have bx. We don't have to write the 1. Now, to get x by itself, you must divide both sides by b, and b divided by b is 1. I'm going to start with writing the right side down first. So b divided by b is 1. I have x is equal to cd over b. In 4, a times by x plus c in brackets is equal to e. X must be the subject. The x is inside the bracket, and so we are going to have to use the distributive property and multiply a into the bracket so that we don't have brackets anymore. On the left, we have ax, a times x is ax, plus a times c is ac is equal to e. Now we need to subtract ac from both sides so that we can have the x term on its own on the left-hand side. On the left, it's ax plus ac minus ac, balancing that on the right by subtracting ac as well. On the left, ax plus ac minus ac is equal to ax is equal to e minus ac. On the left here, we have a times x. To isolate the x, we will divide by a. And then we have to divide both terms on the right-hand side by a. So on the left, we divide by a and both terms on the right-hand side. On the left, a divided by a is 1x. On the right, e divided by a is ea. Minus a divided by a is 1c. In question 5, p is equal to pi x plus b squared. X must be the subject. We're going to subtract b squared from both sides. Subtract b squared from the left-hand side and subtract b squared from the right-hand side. On the left-hand side, you have p minus b squared is equal to pi x. because b squared minus b squared gives you 0. Now, on the left-hand side, there's x that needs to be your subject. You must divide by pi to isolate the x. On the left, you divide both terms. So it's p over pi minus b squared over pi. On the right is equal to pi x divided by pi. I'm going to write the right-hand side down first so that x is the subject. Pi divided by pi is 1. X is equal to p over pi minus b squared over pi. Number 6, bx over d squared is equal to t. And there's x, which must be the subject. The first step is going to be to eliminate the fraction d squared and do this by multiplying both sides by d squared. On the left, you multiply by d squared and you balance that by multiplying d squared on the right. Your result on the left, d squared minus d squared is 1 bx is equal to td squared. On the left, there's x. We need to isolate it from the b by dividing both sides by b. On the left, bx is divided by b, and then we divide by b on the right to balance. The result, b divided by b is 1x is equal to td squared over b. Question 7 has pi minus x is equal to b. In the previous exercise, if you remember, when the x term was negative, we dealt with it by adding x to both sides. That makes the x term appear on the other side, but this time it is positive. So let's do that. On the left side, we add x, and then we balance that with adding x on the same side. The effect of that is that x minus x gives you 0, so the x disappears from the left-hand side and it comes up as a positive term on the right-hand side. On the left we have pi, and on the right is b plus x. To get rid of the b term, over here we're going to subtract b from both sides. On the left we'll have pi minus b, and on the right b minus b plus x. The result of that on the left is pi is equal to b minus b is 0 plus x. Write that so that x is the subject and we get x is equal to pi. Question 8 has the same situation. It's ab minus dx is equal to c. X must be the subject. Our x term is negative, so we're going to add that term to both sides. Add dx to both sides. On the left we add dx, and on the right we add dx to balance it. On the left our result is ab minus dx plus dx, which will just give me ab, is equal to c plus dx. Now the c term needs to go from this side, so we're going to subtract it from both sides. On the left it's ab minus c, on the right c minus c plus dx. On the left we have ab minus c, and on the right c minus c is 0, so we just have dx. Now we need to divide by the d to isolate the x, and so we're going to have to divide both of these terms by d as well. On the left, it's ab over d minus c over d is equal to dx over d. I'm going to start with the right-hand side, sorry. So d over d gives me 1, and so I have 1x is equal to, and now the left-hand side, ab over d, which cannot be simplified, minus c over d, which also can't be simplified. In question 9, it's a over x is equal to b. X, which we have to make the subject, is in the denominator, which is a bit awkward. I'm going to multiply both sides by x, and you'll see it's a bit of magic maths. On the left, we multiply by x, and on the right, we do the same to balance. On the left, we have x divided by x is 1, so it's 1a, and on the right is equal to bx. You see why I call it magic maths? Because x isn't in the denominator anymore, and our fractions have disappeared. All that is left for us to do is to divide by b here to isolate x, and divide by b on that side to balance it. So on the right, we divide by b, and on the left, we do the same to balance it. I'm going to write the right-hand side first so that x is the subject. B divided by b is 1x is equal to a over b. And we're done. The next two questions both have x in the denominator, there and over there. So we're going to practice magic maths again. In number 10, it's a plus b over x is equal to c. I'm going to multiply both sides of this equation by x so that I'll both get rid of my fractions and x won't be in the denominator anymore. The fraction line also operates like a bracket. Multiply the left by x and the right by x. On the left, x divided by x is 1, and so I have a plus b, and I don't need that bracket anymore, is equal to cx. On the right, I must divide by c to isolate the x. Divide by c. Divide both these terms by c. And now I'm going to write the right-hand term first so that x is the subject. C divided by c is 1. X is equal to the left-hand side. A over c plus b over c. And we're done. In number 11, x is in the denominator again, and so I need some magic maths. Before I can do magic maths, I must subtract q from both sides, so it is just the x term sitting on the right side. On the right, I'm going to subtract q so that I can isolate my x term, and I balance that with subtracting q on the left side. On the left, I have p minus q, and on the right, q minus q is 0, so it is just s over x. Now I'm ready to practice magic maths. On the right, I multiply by x to get rid of the fraction x, but it's a little bit more tricky on the left-hand side. If I took p minus q and multiplied both of them by x, I would get xp minus xq. And then I've got x in two terms, which is going to make it really difficult for me to write x as the subject. So what I do is I bracket the p and q, and I simply multiply both of them by x, but I don't actually distribute that x. On the left, I will have x multiplied by p minus q, and I'm not going to distribute that. And then on the right, I have s, because x divided by x is 1. Now it's quite easy. I need to isolate the x on the right-hand side, so I divide by p minus q, and then I balance it by dividing by p minus q on the right. So I'm going to divide by p minus q on the left, and then balance it by dividing by p minus q on the right. Let's see what I've done. P minus q divided by p minus q is 1, x on the left, and on the right I have s divided by p minus q. The last few questions are of a slightly different format. You have to change the subject to the letter in brackets. In question 12, a is equal to 2 pi r, and we have to make r the subject. So I've highlighted r in green as always. To isolate r from 2 pi r, we need to divide both sides by 2 pi. We divide by 2 pi on the left and we divide by 2 pi on the right. On the left we have a over 2 pi is equal to, on the right, 2 pi divided by 2 pi is 1, and so we have r, and we make r the subject. So r is equal to a over 2 pi. In question 13, v is equal to 1/3 pi r squared h. H must be the subject. The first thing is to multiply both sides by 3 so that you're not working with a fraction. Multiply by 3 on the left and 3 on the right so that it balances. On the left you have 3v, and on the right 3 divided by 3 is 1, times 1 is 1, so you have pi r squared h. You need to isolate your h, so you're going to divide both sides by pi r squared. Divide the left by pi r squared, divide the right by pi r squared. And now I'm going to write the right-hand side first so that h is the subject. On the right-hand side, the pi r squareds divide out and you have 1h is equal to the left-hand side 3v over pi r squared. Some of you may recognize number 14 as the equation of a straight line. Y is equal to mx plus c. We need to make x the subject. We are first going to subtract c from both sides so that we don't have the plus c term together on the same side as x. We're going to subtract c from both sides, so there it is. On the left you have y minus c is equal to mx, and c minus c gives you 0. On the right-hand side, where the x term is, we'll divide by m to isolate the x, and we'll divide both of these terms by m. So let's do that. Y over m minus c over m is equal to mx over m. I'm going to write the right-hand side first so that x is the subject. M divided by m is 1. X is equal to the left-hand side y over m minus c over m. Question 15. V squared is equal to u squared plus 2as, and s must be the subject. The s is sitting in this term, so I'm going to subtract u squared from both sides. V squared minus u squared is equal to u squared minus u squared plus 2as. So I've subtracted u squared from both sides. On the left side, I have v squared minus u squared, and on the right, u squared minus u squared is 0, and so I have 2as. To isolate s, we need to divide by 2a on both sides, and on the left side, we'll have to divide each term. Divide v squared by 2a and divide u squared by 2a, and the right-hand side you divide by 2a as well. I'm going to write the right-hand side first. 2a divided by 2a is equal to 1. S is equal to, and now the left-hand side, v squared over 2a minus u squared over 2a. Question 16, m is equal to 1/2 a plus b. So instead of distributing that half to a and b, I'll multiply both sides by 2 to get rid of my fraction. On the left, I'm going to multiply by 2, and I'm going to multiply by 2 on the right as well. On the left, I have 2m is equal to, on the right, 2 divided by 2 is 1, and then a plus b. I don't need that bracket anymore. I'm trying to get to the a, so I'm going to subtract b from both. Subtract b from the left and subtract b from the right. On the left, I have 2m minus b is equal to b minus b equals 0, so I have a, and then I'm going to write it with a as the subject. A is equal to 2m minus b. There are two nasty looking sums to finish off with. But that's the thing about maths. Even when you look at a sum, you think, I don't know what to do, or I can't do it. If you switch that around and say, what can I do? Often the puzzle just falls into place. So in number 17, S is equal to n over 2, 2a plus n minus 1d, with brackets inside brackets, and we've got to get to the a. So what can you do? Well, you can multiply both sides by 2 so that you'll get rid of that fraction. Multiply the left hand by 2, so you've got 2s, and multiply the right side by 2. On the left side, it is 2s. On the right side, 2 divided by 2 is 1n. And then you still have the 2a plus n minus 1d. A is still tucked away inside this bracket here. So I'm going to divide both sides by n to get rid of this n on the outside of the first bracket. 2s divided by n, and then this is one term, so I divide it by n. Left, I have 2s over n is equal to n over n is 1. So now I don't need those curly brackets anymore. 2a plus n minus 1d. Things are starting to look much better. On the left, I have 2s over n. On the right, I have 2a, which is the term where my a is, and then this is all one term. So I can actually get rid of the n minus 1d term by subtracting it from both sides. I'm subtracting n minus 1d on the left to get rid of that second term, and what I do to one side, I must do to the other. On the left, I have 2s over n minus n minus 1d is equal to 2a, because plus n minus 1d minus n minus 1d gives me 0. And now things are really taking shape. If I divide by 2 on that side, 2 divided by 2 is 1, and so I'll just have a. And then I need to divide each term on the left-hand side by 2. So I divide by 2, there's the first term, and I divide this term by 2. The first term on the left-hand side, 2 divided by 2 is 1. So I have s over n minus, I can't simplify the next term, n minus 1d over 2 is equal to, and on the right side, a. Writing it the other way around, you've made a the subject of your formula. And in the last one, s is equal to a, 1 minus r to the n over 1 minus r. A has to be my subject. I have explained several times that this fraction line operates like a bracket, and I'm going to draw that bracket in now as well. If I multiply both sides by 1 minus r, I will have got rid of my fraction. Multiply the left by 1 minus r, and multiply the right by 1 minus r. The left is s, 1 minus r, and on the right, 1 minus r divided by 1 minus r gives us 1, and so we are left with a 1 minus r to the n. We've got rid of our fractions. To isolate a, we need to divide by that bracket, 1 minus r to the n on both sides. We're going to divide by 1 minus r to the n on the left and divide by 1 minus r to the n on the right. Dealing with the right-hand side first, 1 minus r to the n divided by 1 minus r to the n is 1, and so I have 1a is equal to what is on the left. 1 minus r over 1 minus r to the n. And if you got those last two, you're doing really, really well with changing the subject.